Thank you for inviting me to the meetup. My name is William Louth. I was one of the original guys behind the Instana inception, but before they formed the company, I left. So I'm like actually there was 5 of us, so I'm the 5th Beatle, and then I just recently joined back into Instana. So a bit of background, I basically work in building systems that are self-adaptive software, cybernetics, applying that. I've 19 years building application performance monitoring products. There's a website, my Twitter handle is Autoletics, and there's a website called autoletics.com. And you can find out the other products I built there. So my research quickly is on, I look at what's happening in the market on microservices, containers, event architectures, reactive systems, agents. And then I try to see how that's going to impact observability, controllability, which is the area I really focus a lot on, and operability, which is an area that's coming on up. So observability, I'll go into how I see that compared to how it's being promoted. And then we'll talk about what controllability is, which is what the purpose of observability. So when I remember, like when Instana was informing, we looked at what the market is, and typically you have trace information, logs and metrics are all in some data store, and then people have tools that are querying and using a database and the console. And our view was that had to change. And coming from probably more of a science background, I wanted to build something that was more a simulation or a mirror of the system. So our view was that things were going to be sensed. You would have sensors in environments. Agents would be, of course, the ones who do deploy the sensors. The agents would do discovery, identify entities. Today, entities would be containers or anything that's of interest to yourself. And then what we're looking for is what behavior that they do. Now, today, observability is really taking 2 directions. The one direction is where we're going from logging to tracing to metrics and further down, which is the bottom chart. And this is really about reconstructive, explorative data analysis, focus on developers, really for machines. Even though still today we're probably a lot of the tooling is geared towards humans. Unfortunately, this is not very effective for DevOps. Did that flicker? So, sorry. I hope it doesn't keep doing that. But in terms of, when it comes to a model, it's not very effective because the problem is you're dealing with data and not insight, not significance, not a signal. And I think what we need to look at a newer model for these things, that this is data, but this is not control. This is not a system that you can build a control around. You cannot build control around log records and pattern matching in there. So I see another area where it's going to be less data, but it's really going to be about effectiveness for DevOps and focus on humans, or focus on a model that's easy to digest for humans. So logging to observability today, we have this concept of the 3 pillars, and that's logging, metrics, and tracing. That's observability is defined today. I don't define it that way. I define it as more abstract. That we should see that logging, metrics, and tracing are really just a model of what happens. You want to first measure something. And then when you measure it, you want to turn that measurement into something else. A measurement is, I want to count the event. So let's say an event happens. You want to turn it into a counter. You want to turn it into a trace. You want to turn it into a log record. That's the model that's generated from the measurement. And so really what we should be looking at is that the 3 things that found observability is, what do we measure, or how we instrument? From that measurement, what is the model that we generate? And we can actually generate multiple models, and not just the models that we have today. And I think that's where we're limited. When we look at logging, metrics, and tracing, this is a thing that we're going on for 20 years. And yet we have microservices, and we haven't adapted the tooling to it. I mean, distributed tracing is a little bit there, but we've had that a long time. I built the first distributed tracing product, I think in 2000. And we're still talking about distributed tracing today, and I've moved on from that. So I think it's not suitable for microservices and other systems that are more regulating or adapting, especially where Kubernetes and all. And then, of course, when you have a model, what do you want to do with it? Well, the model is about memory. You want to store the changes to the model. So models are not just events, it's what happens to the model and memory of that model. And this is how humans work. And a lot of my research is really about looking how the human brain works and trying to map that to how APM products should work, because the more aligned we get with human mind and the human behavior or how we assess memory, the better the tooling will be. Of course, you want it to augment, you don't want to give an exact replica of a human mind because there are weaknesses within the mind. But you want some augmentation, but you still have to reflect how people work. Okay, so in terms of measurement, of course, the more measurement you have, the greater the overhead. Overhead means less accuracy. Again, with model, the more you collect in your environment, transport goes up, attention goes down, because you have to see everything. When you start to collect everything, then you have to say, what should I watch? And humans are very good at attention, focusing our attention, being very careful, being very cost effective. Our brain is designed to just pick out the significant events. But today, observability is like more data. The more data, and eventually I'll figure out what that data will mean. And I don't think that's right, and we'll come to it. So memory, of course, the more data you have increases the storage, but then significance is what is significant within my storage. And then we have the problem of, when do I get rid of the storage? Because if I don't know what's significant, I'm probably going to keep it around. And that's where we have this kind of data gravity where no one's deleting anything anymore because people are scared that they might need it for some reason. When we look at tools today, what you see in the observability space is that a lot of tools are just pumping data to storage systems, to back-end systems, and they're just piping it into another storage. And then it has a nice fancy tool on top of it to pivot around the data. And this to me is really about where Google was when it came to search. Search was about, remember the beginning of the internet? We all had to type in something, and then we spent all time trying to figure out what labels or what was going to give us a correct page, where we were going to hit. You spent understanding, should I put a plus in front of this word? And that's where we kind of are with logging tools and other metrics. We're trying to type something in and match it to something. And that's really, in terms of memory, the mind has two. We think about recalling something, but there are two aspects to recollection. There's the kind of recollection that we have recalling an event, and that's typically like search, where you recall in a specific event, like what did I do last Friday? Or like what I'll be telling people tomorrow what I did yesterday. I'm going to recall that from my memory. And that's where I search for something, because I'll say, I was in London, and then that cue will trigger the memory and bring it in. But Google changed that itself, because Google started moving into suggestion. And I think that's where also APM products and observability have to do, is it's not about recalling the exact event. It's saying, is this similar to other events? I want to know, am I looking at something that's similar or is it different? And then signifying that. And that's where then we come down to suggestion. Observability tools have to move more to suggesting stuff to humans. They cannot be searching. Logging tools have about 200 fields, and there's vendors who are, proud of more fields they have. But the problem is, who knows which field I need to start with? And if you're not the developer of the code, it's going to be hard to figure out which log message you're looking for. And then it changes. So I think we have to start thinking of newer models where are not focused on just the data or translation of the data. How am I going for time, Bat? Oh. Okay, so observability really comes down to about controllability. It's about having data and then using that in a control system to change our attention and then to act on it. And that's what DevOps really is all about. To me, controllability is DevOps. The data today is too passive. Is what do I do with the data? When I see data, how do I attend to it? Where do I bring my focus? And then what actions I perform? Some of those actions today will be done by software, and we already see that with service meshes, rate limiting things where they're seeing, retries and backoffs. And then of course human intervention, and we have to kind of bring that together. Observability is really still very information based. Where monitoring, which is what DevOps is, and not the old monitoring where we do a ping, monitoring is the process, it's the second order cybernetics of how we regulate observability. So I don't think monitoring is something second class. I don't think it's something that we should discard. Monitoring is the process where we say what should we observe, when it, and how we react to that, and how we control it, and then from there do management. We think of cybernetics, we think of system dynamics. In controls theory, we have basically a control system where data flows in, it goes into a process, output, and then there's a sensor and there's feedback loops between that. And that regulates the controller. That's what observability needs to do. And I want you to all to think about every time you create a metric, say to yourself, what will this metric do? Can I attach an action to it? And if you can, or can I attach a signal to it? And a signal is something that really means very clear what it is. It's not like if you don't know what all of this sort of 10 other things, you won't understand this message. If you don't understand the technology stack, it's not a log message. We need a signal. What is a signal? And a signal, the best way to explain a signal is, it's like an emoji. If you see a flame, it's a flame. The server's going down. We need instant symbols within our system to indicate what's happening rather than a log message that then needs to be interpreted depending on the developer. In systems thinking, we have this concept of inflow, which is if you go back to it, it's very like control theory. Systems thinking is about you have a stock, which is like your capacity in your capacity in your network, your capacity in your pods, your Kubernetes, or your capacity in the number of threads in your pool. And basically inflow is where you take some of that, or the request is being done, it takes away the stock, and the outflow, of course, returns it when the request is over. So the way then to look at it, especially when I know there's a talk later on traffic management really is this, is basically as something comes in, you take a token from a buffer or a pool, like a semaphore, and then you return it when you finish. And so what we need to do is observe that. But that observing, we could see it coming in and returning the token, but that's not really controllability. Controllability is where we change the stock. So my thinking is, my vision for the future is, and much like children when they pick up a ball, the first thing they pick up some object, they hit it around and move it and see what the reaction is. And I think, and it sounds a bit crazy, but in the future, we're going to have more, the observability will feed controllability systems. And there'll be like about 6 or 7 gauges. And our DevOps people will have these dials. And what that dial will be the stock. Will be the stock of the system, because nothing can be done unless you have something in the stock, and then you have to return it. And the future of DevOps will be, initially I think will happen, is because humans don't want to give up control to AI or like that initially, is that we'll all start dialing these things up and down. Because everything is changing a lot. We have a system code deployments are happening, and it's very hard to make memory of anything anymore, because 15 minutes later someone might have deployed something and it's a very different system. So what do you do when you can't have the old way of monitoring where nothing changed in 6 months and everybody knows what the pattern looks like? It's like, I know that pattern, and then as soon as it changes, I know what that means. You don't know that anymore, because you don't know whether it's because of a change, because of the environment, because of the workloads. It's very changeable environment. So I think we have to give up thinking that we're in control and at least in control by just observing, and we have to start experimenting. We have to be able to dial up and down in operations and see what happens. The great thing about that is you can see your immediate reaction. You can see the immediate response in your environment. You tweak something, you bring it up, you see if I add capacity, what happens. That improves, but another bottleneck forms. And I think that's the future of DevOps is learning. Initially, you'll probably have about 12 of these dials, and then someone will come along and say, here's 3 of them that do all the other 12. And eventually someone will say, here's an AI which will do it. And all you have to do is tell the AI, how sensitive do you want to be? What's your risk level? I remember in Interstellar when the guy said, I think, the robot, I forgot his name, but the robot had a level of joke, a level of humor. And I think that's the way for humans. We're good at exploring our limits, moving down and relating to the context. And I think that's where observability is going. We're going to start using observability to control, and the control when we do things will impact the observability. We'll have an immediate feedback on the system. We'll see what that does, and we'll learn how the system works. Of course, you want some safeguards, because no one wants to go, let's dial it down to 0 and everything crashes. No one wants that, but there will be, I think we need to do some experimentation on that, because there's no optimal system. Do I have 5 more minutes? Yeah. Okay. Okay. So that's the part where control comes in, observability. Now get back to humans, because we can't manage systems the way they are today with the data that we're getting in. So how do we go back to building systems that are going to be easier for humans to operate? So we got that control, but still I don't know whether I should intervene. I can tie it to a metric, but I've gone into banks and they are proud of saying they have thousands of metrics. But no one really understands what metric is useful or as a signal. And then they say, well, we'll just apply machine learning to it. And that will figure it out. And everybody say, yeah, that's it. That I can tell you doesn't. Yeah. And the other initiative is we'll standardize on all the names. Everybody always wants to do that. The problem is we're just naming everything differently. And then we need pattern language. We'll get patterns, we'll put the alerts in. No one does that. The new guy comes in, he's like, okay, I'm going to do it. He has to have OCD, first of all. You have to have him doing it for a month, and then he burns out, and no one ever... And the next guy comes in, he starts all over again. Oh, I don't like the way he did the patterns. And those patterns are probably not even valid anymore. And it's changing, so I think we have to get rid of looking at logs. Logs are a last resort to me. So the way it works in the animal world, and this is what I looked at, is animals communicate very effectively. They just go like, "Argh!" And it's a signal. And you know what? It's universal. You don't have to send a message and say, this is the timestamp. It was on this server. I want to tell you, these are the 4 parameters I did to it, like the intensity. You see it. It's aggressive. And you infer the state. And what happens when he does it a few times? You think he's mental. The first time it's like, okay, he's a bit angry. The second time, could be a problem with this guy. Then you realize he's always angry. And what's happened there? We've taken a set of signals and we've inferred a state. We say that this person is an angry person. And that's how humans work. And I think that's how we need to do machines. So my view is microservices or all other systems are going to have to send signals. Emojis, whatever. They have to be something that says, I don't need to read the content. As soon as I see it, I know what it is. A single word, no more text. And those signals are so common. I think I've defined about 15 at the moment. I've looked at different systems and I think about 15 can cover everything that we need in the distributed world. And those 15 signals map to states. Now, there's no state like on or off. It's like, am I defective? Am I degraded? Like what happens when you time out? You're degraded. What happens when you fall back to a cache or fall back to something? Yeah, it's degraded, yeah? Defective is when you start erroring. So we can take a bunch of all of these signals of how services are working, like their social, and build up a Twitter sphere from machines. Now, I know that sounds a bit corny, but basically what we need to do is, and how monitoring used to work in the past, and I know I'm overrunning my thing, but the internet has allowed me, is we have to look at humans take signals, we process them very efficiently, we infer state. We need to do that for microservices. And what's good about that when we start doing that is, instead of asking the service, are you feeling good? Are you operating? We'll ask all of its dependents. Are you talking? So S1 talks to S2. And S2 will tell you how it feels about S2. S1, we need all of the services, a social system where services vote each other out of the containers, out of the pod. So basically they say, I don't think he's operating well. And what the beauty of that is that we can have sensitivity. Because let's say I'm a very resilient system and I can tolerate someone failing. But I might have a colleague that can't tolerate someone. And he has his critical path or something. There we can define his level of sensitivity to certain signals from another service differently than mine. So then collectively we make a judgment on what the other service is. I could vote, I'm happy with him even though he's failing because I have a fallback or a cache or something, or I'm able to retry a few times. But the other guy might say, I can't retry because I got critical time limits. And for me, he's bad. So, and of course, the other guy might be thinking, well, I feel good. I'm servicing everybody. He doesn't know he's even timing out. He might not even know that other people can't connect with him. So the future is going to be looking as a collective system and everybody voting on what is the state of the system. And I think users will also be included in that. And I know we're running out of my time, so I'm going to end very quickly. Just this last slide. Why do we need the signals and the states? It's a small symbolic language. It's compressible. It scales. It will scale across different technologies because it's translatable. It doesn't matter what animal, any animal growls at you, you know what already you're in trouble. It's universal. So we need a universal language across languages, across frameworks. The signals and the sequencing are ways of easily effective fingerprinting. Fingerprinting of behavior in Windows. The fingerprinting drives us down to the metrics. We still go back to metrics because we still need to understand something. But we use the signals to draw to our attention to focus on areas, and from the metrics to the traces. Not the other way today is like I just scan anywhere. And then the good thing about that is it's easy to do familiarity, and then also we can forget all of the other stuff. The left and the right, if it's not interesting, let's start forgetting. Humans do that, and it's important to forget because you need to incorporate new information all the time because it is changing every day. Cheers.